So hello, everyone. Hopefully, I don't need to introduce myself because you saw me yesterday in the keynote. I am Ben Armstrong. I'm a program manager at Microsoft working on Hyper-V. And I'm here today to talk and go deep about all the features and functionalities that are coming in the Windows Server 2012 R2 release of Hyper-V. So I'm hoping that you're going to get excited. You're going to go away and go, I need to go play with some of those features. And I hope we get to have some fun today showing this. I hope all my demos work. Fingers crossed. I have a lot of demos in this session, and that always makes me nervous. So the first thing I want to talk about is the current release, 2012. We have had a fantastic success with this release. We really have. I have lost track of the number of people who I've talked to who have been pulling out VMware and deploying 2012. I have lost track of the number of people who have been really quick to adopt this. And there's a lot of cool stuff here. There are a couple of points I want to make on this slide, though. The first one is, even this week at TechEd Australia, I have had conversations with people where they've come and they've asked me about, hey, Ben, when are you going to do something in this space? And I've responded, well, we did that in 2012. So 2012 was a huge release, and the reality is a lot of people haven't got their head around everything that was in that release. So I'd really encourage you, we did a bunch of stuff at launch last year, take the time to just pull up the videos and have a look and see and get a reminder. And the other thing that I'd like to highlight about 2012 is the most common response that I've heard from people as they were looking at 2012 has been like, man, there's a lot of stuff here. There's too much for me to bite this all off in one hit. I'm going to just take advantage of this new feature and that new feature. Don't forget about the features that you haven't looked at yet. Look at scale-out file server. Look at inbox network teaming. Look at Hyper-V replica. There's just a very long list of really exciting technology in 2012 that I know a lot of people aren't using. The next thing, I'm really happy that we're finally able to talk about this, is 2012 was a big release for us because 2012, first time, the bits that we shipped to you guys, at the same time, we shipped the same bits to Azure. Now, they've always run their own variant of Hyper-V, which has had their customizations, and we've had code going backward and forward. This is the first time that we've been able to go, yep, same bits for both Azure and for you guys. And that's really exciting. I'm really happy about that. And it's already starting to enable some really cool scenarios around being able to easily move virtual machines between your private cloud and an Azure public cloud. So really happy to see that coming out. And finally, just to recap, one thing that you're going to hear Microsoft talking about more and more in the coming years is this whole concept of it's not private versus public cloud. It's not on-premise versus off-premise. It is all of these things. And the great thing for me is I don't care where you're running your stuff because it's going to be running on Hyper-V. So happy. So the first thing I want to talk about is some of the work that we've been doing to move virtualization forward. As I said, 2012 was a great release for us. And we spent a bunch of time talking to customers and listening what was going on. And whenever we're working on a release, there are a couple of things that we like to take into account. Obviously, we listen to the pain points from people using the software. We also obviously look at what our competition is doing. But something that we also try and do is in every release, we try and sit down and go, what can we do as Microsoft that is going to be new, is going to be groundbreaking, is going to be something that no one else has done yet? And there are a couple of cool features that fall into this category in Server 2012 R2. The first one is what we call the Generation 2 virtual machine. Now, if you've used Hyper-V, you're familiar with the Hyper-V virtual machines. Let me give you a bit of history here. I can actually trace the roots of a Hyper-V virtual machine back to Virtual PC 1.0 in 1996, back at Connectix. And when we were developing that software, we were building virtualization for a world that had no idea what virtualization was. So we had to do a lot of work to try and make our virtual machines look and feel just like a physical computer, so that you could install any operating system and have it just work. Well, things are very different today. So let's go through some of the differences. First, over 50% of new server deployments are now virtualized. I've lost track of the number of customers I talk to who say, you know what, virtualization first. Windows is now innately aware of when it's running on a virtual machine. Windows now goes out and finds that, hey, I'm running on a virtual machine. Let me optimize myself for this virtual machine. There's also been changes in the industry as a whole. With all the work that's been going on around ARM computing, around tablets, around different form factors, the PC architecture as a whole has become a lot more flexible. So with a Generation 2 virtual machine, we have got rid of all the pretense of pretending to be a physical computer. And we've built a virtual machine which is unabashedly a virtual machine. And there's a lot of cool things that come with that. I'll be demonstrating that and talking about that in a moment. The next thing we've done is some really fun work around improving the experience interacting with virtual machines. I don't want to talk about this much because it's way more fun to demonstrate. And the final thing, and this one's actually really cool in a nerdy IT pro kind of way. I get excited about this, and if you work with servers, you'll get excited about this. And please do not try and talk about this at the dinner table, because no one will follow you. So when we, a while ago now, actually a long time ago, we realized that people really care about virtual machines. So it was actually Windows Server 2003 R2 where we had the realization of hey, what we should be doing is we should give people extra virtual machine licenses depending on what operating system they buy. And Windows Server 2003 R2 was the first release of Windows where we said, you know what? If you buy the Data Center Edition, we're going to give you unlimited licenses for server virtual machines on top of that. And I got to tell you, we sold more copies of Windows Server 2003 R2 Data Center Edition than we had ever sold Data Center Edition before. It was amazing. So you come forward to today with Windows Server 2012 and Windows Server 2012 R2, and I have to say this time and time again because people just don't get it through their heads. The only differentiation between the different versions of Windows Server, the only differentiation is how many virtual machine licenses you get. So whether you're running the free Hyper-V server, whether you're running Windows Server Standard Edition, whether you're running Windows Server Data Center, the only difference is how many virtual machines you can run. You want to do clustering? Fine, do it on the free version. Do it on the standard version, whatever. You want to run Active Directory? Fine, do it wherever you want. The only difference is the licensing for virtual machines. So with Server 2012, we got to that stage, but we still had this situation where yeah, you could go out and buy Data Center, and it would give you unlimited licenses for virtual machines, and that's all great and so on. But you still had to do key management. You still had to either do it by hand, you still had to use KMS, yada, yada, yada. How many people here like key management? No one? I am shocked. So with Server 2012 R2, we have really simple idea. You put Windows Server 2012 R2 inside of a virtual machine, we reach out and we find out, hey, are we running on an activated and licensed Data Center Edition? And if we are, then we're activated. And there's nothing you have to do. By the way, this feature is impossible to demonstrate, because I could just bring up a VM and go, look, it's activated. And I didn't do anything. But this makes life so much easier. You just don't worry about key management for your server virtual machines now. Done and dusted. The other thing to highlight here, I actually had someone who works in the education and training industry get really excited about this, because he had the problem that he often built training virtual machines that he then distributed. And key management was a nightmare for him, because he didn't want to put his keys in these virtual machines and then have them go out. Well, this completely solves that problem, because now he builds a virtual machine, he puts it on a licensed data center server that he is paid for, but none of his licensing details go into the virtual machine. The virtual machine sees that it's running on a good host, and it's activated. He now takes that virtual machine, gives it to someone else. If they put it on their activated copy of data center, it all just works. If they put it on a standard or a free version, we just come up and say, hey, you need to provide a key now. So that just greatly simplifies things. So really exciting, really hard to demonstrate. Don't talk about it at the dinner table. So now I do want to show you some of the details about Generation 2 virtual machines and the enhanced experience with virtual machines. And of course, my demo laptop has locked itself, as it does. So first, let me bring up 2 virtual machines here. I have a Generation 1 virtual machine and a Generation 2 virtual machine. I get teased about this. I'm really paranoid. I actually run my own domains for these demos, but because I'm lazy, I call my domain Ben, and my user Ben. So you'll see that I'm logging in as Ben@Ben. No, it's got a nice ring to it. So here I have 2 virtual machines. On the left, I've got my Generation 1 virtual machine, and on the right, I've got my Generation 2 virtual machine, and they're both running Windows Server 2012 R2. Different desktops, so you can tell them apart. And for the most part, these just look and feel the same. But if I bring up Device Manager on the Generation 1 virtual machine, you're going to see a lot of crazy stuff in here. Some of my favorite ones, the Pentium 2 processor to PCI bridge. Yeah, we really need one of those in a virtual machine. Side note, we actually, some fun things about like historical perspective here. When the motherboard that we emulate in a Generation 1 virtual machine is a Pentium 2 440BX, because it turns out that's about the most compatible motherboard in the world. However, we have hit some interesting issues in that we do report ourselves as a Pentium 2 440BX that supports up to 64 processors. We've seen some interesting ones with that. But so you can see there's a lot of stuff here that is just there to make an operating system that knows nothing about virtualization happy. So if I come over to the Generation 2 virtual machine, none of that's there. None of it. What we have is we have VM bus, and we have devices that are associated with VM bus. So what does this mean for you? Well, the first thing it means is it's actually a lot simpler to manage. Now, hopefully, you're all familiar with this. I've got my virtual machine settings here. Here are all my options. If I bring up the same UI for Generation 2 virtual machine, you're going to see that half the options are missing. And that's because we don't need them. So we don't have IDE controllers in a Generation 2 virtual machine because we support booting off of SCSI. We don't have legacy network adapters in a Generation 2 virtual machine because we support booting off of virtual network adapters. So we're doing all of this by using the new industry standard of UEFI boot, which unfortunately does mean today Generation 2 virtual machines are Windows 8, Server 2012, and later 64-bit only, because those are the only operating systems that have support for these types of hardware. But we do actually get another benefit from building this system on UEFI, and that is that Generation 2 virtual machines are actually also fully support secure boot, which is a feature we put in Windows 8 that protects you from kernel mode attacks inside your virtual machine. So that's Generation 2, and I'll talk a little bit more about that in a moment. But now I want to show you the enhancements we've made to just interacting with a virtual machine. So we have this interesting discussion that goes on inside of Microsoft. And the interesting discussion is basically like the eternal, like, hey, when do people use the Hyper-V management tools, and when do people use System Center, and what should we be doing in each, and where do we invest, and where does it make sense? And when I go out and talk to people, and I go out and I talk to people who have large deployments using System Center, using System Center Virtual Machine Manager, and I say, hey, you've got SCVMM and you've got their management consoles, so that's the only UI you use, right? You never use the inbox tools? And they're like, no, we use the inbox tools. I'm like, well, why? What's the scenario? And the scenario that they always tell me is, well, we use the inbox tools when we have to troubleshoot a box. If we have a server, and for whatever reason it's not responding to System Center, something weird's going on, and a guy has to go and log in on the box and figure it out, then we're going to use the inbox tools. Well, OK, that makes sense. So the scenario that we focus on now is we focus on using the inbox tools when things have gone wrong. So I'm simulating that here. I've got my virtual machine is not connected to a network, pretending that I've got a network problem. So then we say, OK, so you're in a troubleshooting scenario. You've logged into the box. You're using the inbox tools. What's the #1 thing that irritates you? And I love this, because it's just like it's the smallest, most, like it's one of those little things that just really, really irritates people. And it's always the same answer. What's the #1 thing that irritates you? And the #1 thing is, I cannot copy and paste. So who here has tried to copy and paste into a Hyper-V virtual machine? Yeah. Yeah, I love this. So we actually call the way we do this the ghost writer, because that's what we actually do. When you try and paste into a Hyper-V virtual machine, we take any text from the clipboard in the hosting environment, and we simulate someone typing keys on the keyboard. So if you do enough data, you can actually watch the text come in as we're like typing away furiously. So we have listened, and let me just show you. I'm going to bring up, I have a WordPad here, and as you know, with the Ghost Writer, I would never be able to do something like a graphic. If I come over here, there, it now works. And now I'm going to sound like a TV infomercial guy. That's not all. So we can actually copy and paste entire files. So I can copy and paste a file in, and I can copy and paste files out. Once again, great for troubleshooting. You've got a bunch of data in a file, you need to get it in there and configure it. And now I'm just going to be silly, because this actually largely happened by accident. So I've just copy and pasted in a movie file, one of our recent ads for the Surface. And what you're going to see is that I now have full motion video and, that's good, sound inside of a virtual machine. And this is just using the Inbox VM Connect. So how did that work? What's happening here? What we've actually done in this release is we've worked closely with the remote desktop team to be able to integrate the remote desktop protocol and run it directly over VMbus. So even if you have a machine that has no network connectivity, even if it's on a different network, no matter what's happening, we can give you a full remote desktop experience into that virtual machine directly from the VM Connect UI. And because this always surprises people, this works remotely. So I'm doing it locally here, but if I was sitting on this laptop and my server was off somewhere else, all this stuff like copy and pasting files and audio and so on, that works. It also works even if the host is running Core Edition. So I can still connect remotely, get all this great experience. And of course, it works on the free version of Hyper-V. So now let's go a little deep on these features and talk through some of the details. So I'm not going to talk through all of this. I put this slide in there so that when they publish this afterwards, you can get the details and go over it. This is the comparison list of what's in a Generation 1 virtual machine and what's in a Generation 2 virtual machine. Now, a couple of things to call out. People always get really excited about Generation 2 virtual machines. In fact, they get a bit too excited about Generation 2 virtual machines. So every time I do this presentation, afterwards, I'll be talking to people, and they will have made assumptions like, oh, that cool enhanced VM Connect that you showed us, that's only for Generation 2 virtual machines, right? No, I actually just demonstrated that on a Generation 1 virtual machine. All the features that we're doing in this release are present for both Generation 1 and Generation 2. Let me say that again, all the features. I'm going to show you a bunch of features. Every single one of them work for both Generation 1 and Generation 2 virtual machines. The only features that are unique to a Generation 2 virtual machine are you can boot off of a SCSI controller and you can boot off of a virtual network adapter. You don't need a legacy network adapter, and you have secure boot. That's it, those three. So please, let's be crystal clear on that. The next question that comes up is people look at the Generation 2 stuff and they go like, wow, that's going to be a huge performance improvement. The reality is no. Virtual machines are already pretty darn fast. I mean, when we do our server benchmarking and so on, the overheads that we're seeing these days are in the sub 5% vicinity. So even if we halve that, you're not going to notice. There are a couple of interesting places, though, where we do get a performance boost from Generation 2 virtual machines. The first one is actually boot time. Because we have fewer devices to enumerate, we're not doing emulated devices, so on. Generation 2 virtual machines tend to boot about 15% faster than Generation 1 virtual machines. The other one, interestingly enough, is actually operating system install time. You should really try this out. Set up a Generation 1 and a Generation 2 virtual machine side by side. Start the OS install at the same time. The Generation 2 one finishes way before the Generation 1 virtual machine. But for day-to-day running, there's not really that much of a difference. Next thing I'd like to do is just kind of step through the enhanced VM Connect a little. So I love block diagrams, by the way. I have a block diagram. This makes me happy. Block diagrams and arrows. This is my happy place. So I have a block diagram here that just kind of steps through how VM Connect works today. So you have a virtual machine, application in the virtual machine. It wants to draw to the screen, draws to video driver, so on. We grab that, we send it over VM bus. In the worker process in the host, we actually take that and we construct a frame buffer, just a big old bitmap that represents what should be drawn to the screen. You then have VM Connect comes in, and VM Connect sends in keystrokes and mouse coordinates, and we send back bitmaps. This is the experience that we have today. That's the basic experience. Now, with enhanced VM control, we kept this 99% the same. The only difference is now, instead of using the keyboard and video driver inside the virtual machine, we're using remote desktop services inside the virtual machine. So the application talks to remote desktop, but once again, we're sending this over VM bus. We're constructing it in the worker process. VM Connect is connecting. So all the scenarios where VM Connect works today continues to work with the enhanced mode. So that's really cool. That was one of the things that we knew was we didn't want to make this more fragile in any way. So now that I've talked about that, the next thing to talk about is what we've been doing to make Hyper-V better for private cloud. Hopefully, it should come as a surprise to no one here that we spent a lot of time on this release making Hyper-V better for private cloud. Let me give you a tip. If I were a betting man, I would say we're probably going to spend more time on the next release making Hyper-V better for private cloud. So that shouldn't come as a surprise to anyone. But we did spend a lot of time talking to people trying to figure out what are the pain points that exist today and how can we make this better. So the first one that we looked at, zero downtime upgrade. As I mentioned at the beginning, we have a lot of people deploying 2012. We have a lot of momentum around 2012. We're really excited about this. We also knew that we were going to kind of surprise people by coming out with the R2 release so quickly. And what we didn't want was we didn't want people to put their 2012 deployments on hold while they waited for R2. So we made a top priority. We can do cross-version live migration. We can do cross-version pretty much everything with Hyper-V. So you can deploy 2012, and you can move to 2012 R2 when it's available. And I actually have a session tomorrow afternoon, upgrading your private cloud, where I'm going to step through the nuts and bolts of how you take a full private cloud deployment on either 2008 R2 or 2012 and get that to 2012 R2. So that's the first investment that we've made. The next one is faster live migration. We did a little demo of this yesterday. I'm going to be demoing this again in a moment. But we've done two technologies here: faster live migration using compression and faster live migration over SMB direct. We've also added the ability to resize VHDX files online. I always forget about this slide because this is where you get to call me a liar. Because there is one other minor feature for Generation 2 virtual machines here. So we allow you to increase and decrease the size of a VHDX file while the virtual machine is running. However, it's only supported for SCSI disks. We don't support this for IDE disks, which means if you want to do the boot disk, then you need to have a Generation 2 virtual machine. But you can do this while it's running, even on the boot disk, if it's a Generation 2 virtual machine. We also added the ability to do live exports of a virtual machine while it's running. So you can have a running virtual machine, you can make a copy of it without turning it off. Or another cool thing that we've enabled here is you can have a running virtual machine, you can take a snapshot or checkpoint of it, and then you can export that snapshot or checkpoint, all while the virtual machine continues to run. So now I'm going to switch across to my demo, and I will apologize in advance. This is the one demo where I am being a wimp and I'm going to use a video. This is actually a video I took from my lab back in Redmond. So here I have System Center Virtual Machine Manager, and I've just started a live migration between two Server 2012 physical computers. So let me step you through, while this happens, let me step you through the rig a bit. So this is not a high-end fancy rig. For people who know Microsoft, I'm a program manager. Program managers don't get the good hardware. We do get good hardware at Microsoft. First, it goes to the development team, then it goes to the test team, then it goes to the dumpster, and then I pull it out of the dumpster. This is pretty much the workflow. So this is my lab environment that I've set up. It's two clusters. I have a 2012 cluster, which is Boeotia with Calliope and Clio. And then I have a 2012 R2 cluster, which is Mount Helicon with Euterpe and Melpomene. These are all just single processor Core i7s. And for most of this demo, I'm using 4 1 gigabit network adapters teamed. The virtual machine that I'm live migrating is a Windows Server 2012 virtual machine that I've configured with 6 gig of memory. And I've got an active workload running inside of it. And the first thing, as I said, we're doing is we're just doing a live migration between 2012 and 2012. And I do this to kind of get a baseline. So you can see here that migration, it took 66 seconds for the live migration, plus a little bit of orchestration overhead. So the next thing I'm doing straight away is I'm live migrating this virtual machine from 2012 to 2012 R2. So this is, in this video, this is actually a cross-version, cross-cluster live migration. Now, something to highlight is I have to put that text up there because the way we did this, you can't actually tell the difference when you're doing a cross-version live migration. You can do this using System Center Virtual Machine Manager. You can also do it using the inbox tools. And doing a cross-version live migration using the inbox tools, it's just the same as doing a standard live migration. You go in, you find your virtual machine, you say, I want to move this virtual machine where to? That server. And there's nothing to tell you that, like, oh, by the way, that's a 2012 R2 server, because it all just works. So this is going to go ahead, it's going to do a live migration, and it should take about the same amount of time. And once we've done this, we're going to live migrate the virtual machine again, but this time 2012 R2 to 2012 R2 with compression. So a couple of facts and a bit of a story behind compression. The first one is we actually, while we were finishing up on 2012, we had a developer intern come in and do a prototype on compression. And their prototype came back and said, yeah, we can make live migration twice as fast. Now, I got to say, as a program manager, I love it when I've got features where the performance improvement is in the multiples, not the percentages. I'm used to people coming and be like, we can make this 10% faster. So we went back, did a full implementation of compression, we found that on the average workload, we actually see a 3 to 5x speed improvement depending on what's running inside the virtual machine. Because it's compression, it's really going to depend on what's actually in the memory content of the virtual machine. So there we see we've gone from 66 seconds to 18. Now for the fun bit. Now I'm doing some changing behind the scenes, and I'm going to do this live migration again, but this time using SMB Direct, using RDMA. We're going to live migrate the virtual machine back to the source. Now, the story behind the RDMA stuff is, honestly, when we started working on this, we had no idea how fast this was going to be. And it is eye-wateringly fast. You know, it is really amazing to see. So we started at 66 seconds. We came down to 18 with compression. And if my memory serves me right, it now takes 8 seconds with RDMA. 8 seconds. And these are just 2 RDMA adapters. So now, once again, and this is the virtual machine that we've been live migrating. And now I'm going to show you the online resize feature. While I'm doing that, though, I want to call out something. This is the first time ever that I have gone to TechEd Australia and shown a demo using System Center Virtual Machine Manager. Do you know that? First time ever. Because this is the first time ever that we're actually shipping these 2 things at the same time. Like, yay! That is awesome. You know, for me as a guy on the Hyper-V team, every time the System Center team finally got a version that supported me, I was working on the next version. I can't use that. And I know from you guys that I got so much complaints and hate mail about, Ben, like, stop telling me about features that I can't use for another 6 months. So here I've used System Center Virtual Machine Manager. I've resized the VHD. New feature in 2012 R2 already being lit up in System Center Virtual Machine Manager. I come in here, refresh, and now I can go and resize the partition. Side note, I've actually been surprised by a lot of people who don't realize this. Windows does allow you to actively expand and shrink partitions, even boot partitions. A lot of people assume we can't do that. We support doing that since Vista. So you can resize any of these drives, go ahead and do it live. The final thing I'm showing here is the online export. So while this is happening, this is going to do a live clone of our virtual machine. Let me explain why I think online export and live clone is a cool feature. This is one of those features where you see it and you're like, oh, yeah, OK, but why do I care? So there's a little story I like to tell, because any one of us who've worked as a server administrator have probably had this experience. Now, it's a Wednesday afternoon, and you've been asked to go and make a configuration change on a SQL server. And you go and you log into the SQL server, and you're puttering around, you're about to make the change, and the management tool crashes with a funky error message. And now you have a dilemma. Because your dilemma is, clearly something's wrong with this server. But you also know that it's currently functioning as a SQL server. So what do? You have 2 bad choices now. You can either just go like, it's kind of working, and walk away. And and if that server falls over 2 hours later, and they're like, hey, did you know about this? And you're like, yeah, I logged in 2 hours earlier, and something was weird, but I walked away. Ooh, that's not a fun conversation. Alternatively, you could go like, well, this looks like a problem. I'm going to go investigate it and shut the server down. Dear Lord, I hope you find a problem. That's another fun conversation to have. Like, hey, why did you shut down the SQL server? Like, we've been down for 2 hours. Well, something went weird, and I wanted to figure out what was happening. Like, well, what was the problem? Don't know. Rebooted, and it went away. No. So the great thing is, with the online export and the online clone, you can now leave that server running and go, OK, I'm going to make a copy of this. I'm going to take it over to my desktop, and I'm going to do the investigation. It's a much better option. So anyway, I think that's really cool. I like that feature. So now let's talk a little bit more about this. So I showed you cross-version live migration. This is one of those great features where we set out to do cross-version live migration, and we did cross-version everything as a result. So save states, yeah, they now work. Checkpoint snapshots, they now work. So if you do an in-place upgrade from 2012 to 2012 R2 and you've got virtual machines with snapshots, it all just works. It's all fine. You know, in the past, we required you to do this crazy process to get rid of snapshots and so on. I actually particularly like the upgrade experience for Windows 8.1. Now, Windows Server 2012 R2, this is a server. If you try and do an upgrade and you've got running virtual machines, we're going to come up and go like, ooh, like, please move these VMs somewhere else or shut them down, like so on. But Windows 8.1, we go, it's a desktop computer. You know, chances are these are just your dev test machines. So you can have a bunch of running virtual machines on a Windows 8 desktop, and you'll be able to upgrade to 8.1. You'll go like, yeah, I want to upgrade to 8.1. We'll go, OK. And we will just save state your virtual machines, upgrade the operating system, bring it back up, and start your virtual machines back up. And they'll be there and running like nothing happened. I love that. That's really cool. So the next thing to talk about is faster live migration with compression. So one of the questions I always get here is, hey, compression takes CPU. Yes, it does. Yes, it does. So how's that going to affect my running virtual machines? Well, first thing I want to say is most of you are still massively underutilizing your CPUs. You really are. You know, I spend a lot of time talking to people, gathering data, so on. Right now, even in medium to high density Hyper-V deployments, we're seeing an average CPU utilization of around 30%. Trust me, for most of you, CPU, not the issue. But we are mindful of this. We actually designed our compression algorithm so that as we are doing a live migration, we are actively monitoring the CPU load in the host, the CPU request from the virtual machine, and we only use as much CPU as is available. So in a worst case scenario, and we've replicated this in our lab, if you have a server that is just slammed and you try and live migrate a virtual machine off there, even if you have compression turned on, we won't engage compression if there isn't the CPU available to do it. The other one, of course, is the RDMA. And really, the way to think about this is the live migration with compression, that's a free network upgrade that you're getting with 2012 R2. Actually, I had someone tweet that after they tried out the preview. They were like, Hyper-V guys, thanks for the free network upgrade. I don't need to go out and buy anything. The RDMA support is, if you want to build a data center that is just the premium experience, you really need to be looking at RDMA. So as I said, this just blew us out of the water with how fast it was. So when we actually got RDMA up and running, a couple of things to point out. The first one is, not only does RDMA give us blinding network speed, it does so with 0 CPU overhead in the parent. 0. No CPU usage in the host OS at all. And when we got this up and running, we had some test boxes in our lab, and we were like, because RDMA is built on SMB Direct, that's the way we built it, we also have multi-channel support here. We're like, let's see how fast we can make this. Let's just keep on putting RDMA adapters in there and see how it goes. So we started with 2 56 gigabit adapters and a crossover cable. Yeah, good. Then we added 2 more. Like, yeah. Then we added a third one. When we added the third one, we didn't see a performance improvement. We're like, OK, we've bottlenecked somewhere. So we went and we did some investigation, and we had bottlenecked on the PCI bus. Little side note, if you want to do this seriously, you need systems which have PCIe 3. PCIe 2.2, not fast enough. So we went out, we got some new systems, PCIe 3. We put the 2 adapters in. Yeah, we put the third adapter in, like, yeah, it got faster. We put the 4th adapter in, nothing. Nothing. So moving from the 3rd to the 4th adapter, we figured out we were bottlenecked on the speed of memory. We were transferring at 16 gigabytes a second. And we could not read and write memory faster than that. So this is just insanely fast. And as I said, and this stuff is surprisingly not that expensive. So if you want to build the best data center with just optimal storage, network, mobility, you really need to be looking at the RDMA stuff. So a little point, I often get asked, like, hey, when do we use compression? When do we use SMP Direct? Really simple guidance here. How much bandwidth do you have available for live migration? If it's under 10 gigabit, if it's 10 gigabit or less, use compression. If it's over 10 gigabit, use SMP Direct. We've done huge amounts of testing, and every time this guidance bears out. So then what else have we done? The next thing we've done is we've actually done a huge investment in our support for Linux and bringing it up to the same level of our support for Windows. We've done dynamic memory support. We've done online backup support. We've made sure that the new online VHDX resize feature works with Linux as well. We've built a new video driver, and I'll be demonstrating all of this in just a moment. We've also added support for storage QoS. So you can now go in and control how much storage bandwidth individual virtual machines use. So you don't have to worry about a heavy utilization database causing performance problems for other systems. This one is actually a big one. We've added support for guest clustering with shared VHDX. And the key thing to point out here is this is not a dev test thing. This is a production environment. I'll talk more about that in a moment, too. We've also made enhancements in Replica. Hopefully, you're getting the theme that there's a lot in the R2 release. This is not just a service pack. So I'm now going to jump over to my system, and I want to demonstrate a whole bunch of this stuff for you so you can see hands-on what it looks like. So I'm going to start by looking at the improvements that we've made around Linux. I'm going to bring up two virtual machines, and first I have to head this one off at the gate, because this one always comes up. I'm going to demonstrate CentOS without the latest integration components and SLES with the latest integration components. This is not me trying to say that SLES is somehow better than CentOS or that Microsoft has a preference in Linux distributions. Please do not read that at all. This is merely the VMs that I happen to have handy. So the first thing we've done is, it's a small thing, but it's the sort of thing, much like the copy and paste. It's the small thing, but it's the sort of thing that will slowly drive a system administrator insane. And that is, prior to 2012 R2, we haven't had a native video driver in Linux. And where you can actually see this is if I'm on my CentOS machine, see how I have the mouse following the mouse? We actually, on the development team, you get this mode whenever you have a guest operating system where we have an enlightened mouse driver, but we do not have an enlightened video driver. And on the development team, we call this mode cat and cheese. Sorry, mouse and cheese, because the mouse follows the cheese around the screen. So there, yeah, cat and mouse, mouse and cheese, it all works. So now on this system, I don't have that. I have a single cursor, nothing following it around. But the other one, this one is actually one that I'm really excited about, is the dynamic memory support for Linux. So if you have a look here, here's my SUSE virtual machine. I started it up with 1 gig of memory. My poor little laptop here only has 8 gig of memory, and I'm running far too many virtual machines, so it's pretty much out of memory right now. And you can see that we've boiled down the virtual machine. We're down to 652 meg. But let's be mean to it. So I've got this nice little script that we can just start allocating memory. And what you're going to see is, because I'm out of memory, you'll actually see that the memory for all my virtual machines goes down as my SUSE virtual machine pulls the memory out of them and says, I need it. I had to make this demo work, I had to set the SUSE virtual machine to be high priority in dynamic memory. So I'm just going to keep on adding memory and really hurt my other virtual machines. They're not happy with me now? Key thing to highlight here, though, is look, I am now going over the amount of memory I started up with. So this is the full dynamic memory. This is add and remove. And it got angry at me. I just do that until it runs out of memory. So now it's freed the memory, and it all goes back, and all my other virtual machines get happy again. So that's cool. It's the full thing. A lot of people that when we talk to them about Linux dynamic memory assume that we would just be doing ballooning. We're doing the full hot add, hot remove, pressure reporting, the entire dynamic memory experience. So next thing I want to demonstrate is something that's a bit boring. That's backup support. But I have to do my straw poll here. So first, question that you never thought you'd get asked at TechEd. How many people here have Linux servers in their environment? Yeah, OK. I'd say just over half of you are willing to admit that you have a Linux server in your environment at TechEd. Now for the fun thing. So of all you people who have Linux, how many of you have a backup strategy for your Linux servers? That is not as many people. Now for the really fun one. I love this. This is when I get to make Linux people uncomfortable. So of all you people with a backup strategy, be honest, how many of you is it more than a shell script that copies files every night? That's actually impressive. I'm not going to ask how many of you are going like, it's more than that. I use tar. That's not copying files. So what we've actually built in this release is we've done work so that you can now do a file system consistent backup of a Linux virtual machine using the Windows VSS infrastructure. So I'm going to come in here. I'm going to find my SUSE virtual machine. And it's going to tell me it can do an online backup of it. I'm going to choose the right option here, because if I choose the wrong option, it fails, and it's terribly embarrassing. And I'm going to back up this virtual machine. And now what's going to happen is, on the parent side, we're using Windows VSS and going through the whole process requesting a backup. In the Linux side, we have integration components that Linux doesn't have an equivalent of VSS, but we issue a file system freeze. So the cool thing about this is what this means now is if you have enterprise-grade Windows backup in your environment, whoever it's from, whether it's EMC, Symantec, IBM, Veeam, DPM, whatever, you can now use that software to do a zero downtime, data-consistent backup of your Linux virtual machines. Now, I know since we've started transferring data, we've already taken a snapshot of this virtual machine, and it was running the whole way through. So that's actually really cool. I would now happily argue that even if you don't care about virtualization, you should look at Hyper-V because it makes it easier to back up your Linux servers. So there we go. Let me minimize this. So that's kind of the Linux spiel. And look, we're backing up. So a couple of other things that I want to show you. First one is, let's talk about the shared VHDX functionality. I'm going to bring up this virtual machine, and it is configured in a virtual machine cluster. Need to log in. I'm really pushing my system on memory, so things are a bit slow. And what I'd like to explain while I'm showing you this is why this really matters. Because I've had a lot of people look at shared VHDX and go, oh, yeah, that's kind of cool. But when I step through the real behind-the-scenes story, that's when people get excited. So I have this virtual machine here. It's part of a cluster. You can see I have my Quorum disk. I have my CSV volume inside the virtual machine. If I bring up the settings for this virtual machine, what you're actually going to see is those are just VHDX files that are themselves residing on a scale-out file server. So what we actually do here, and I mentioned when I showed you the slide, this is not dev test. This is enterprise grade. What we do is we only support shared VHDX for clustering if the VHDX file is running either on a scale-out file server or on a CSV volume. And we actually take advantage of the highly available nature of the platform and the support in the platform to then deliver HA storage inside the virtual machine. So how many people here have clustered virtual machines today? Okay? So of you, how many of you have to have separate storage configured for those clustered virtual machines? And you like having separate storage? No? No. Well, you don't need to anymore. No, this is the key story here is what we want is we want you to be able to just like have a single amount of storage. Whether it's a CSV volume, whether it's a scale-out file server, just have a single place for your virtual machines. You no longer have to special case clustered virtual machines. You now just go like, yes, I have virtual machines, and for their storage, I have a CSV volume or a scale-out file server, and I have virtual hard drives on there. And if it's clustered, then I check a checkbox in the UI, and now it's clustered. You don't have to do LUN management, you don't have to do provisioning, you don't have to do a whole lot of stuff. One of the things that we're actually watching very closely here, we've talked to a lot of service providers who are really excited about this. Because today, most service providers will not offer clustered virtual machines. Because in order for a service provider to offer a clustered virtual machine, they have to let the user see into their storage backend. And that is a big no-no. Now with shared VHDX, if you're in a situation where the users of your virtual machines are completely separated from your hardware and your virtualization infrastructure, they don't have to know anything about the underlying fabric here. That's really cool. So let's get rid of that, and let's jump over and talk about I/O. Bring this up. My backup's finished. I have to log in a lot for these demos. So here I have a virtual machine, and let's do a little role play here. I'm going to imagine that I'm going to pick on Phil, because I know Phil. Phil here is a local service provider, and I have bought a virtual machine from Phil. And one day I got in, and I've just started the biggest database workload that I have. And it's soaking up all the I/O, and I've gone out to lunch. I'm a happy man. Now, right now, Phil is about to not be a happy man. Because in a couple of seconds, Phil is going to start getting phone calls from other people saying, what's happened to my virtual machine? Everything was fine, and now performance has just gone down the tubes. Okay? Now, I've talked to people in this scenario, and not dissing Phil at all. Phil's a great guy. He would never do this to you. But I have talked to people who, when they did this, and when their host or service provider got those phone calls, their response was to turn off the VM. Because the service provider went like, ooh, I've got 10 angry people, and if I turn off this VM, I've got 1 angry person, and that's an improvement of 9 people. Yeah! It doesn't work that way, please. That's not the way you do customer service. So now, with Server 2012 R2, what Phil can do is he doesn't have to turn off my virtual machine. He's going to come here, and he's just going to say, you know what, this virtual machine, it's using too much. I'm going to restrict it. Let's say 250 IOPS. And instantaneously, no downtime, no effect to me, the IOPS are down. For people who aren't familiar with IOPS, 250 IOPS is about the performance of a RAID 1 SATA 2 disk. So from my point of view, the only effect to me now is my workload's going to take longer to complete. I don't care, I went out to lunch. But now, Phil's environment is not affected. Other people's VMs are running correctly, and things are great. Best case scenario, I call Phil up and say, hey, I want things to run faster, and he says, how much are you willing to pay? And I say, well, a fair amount. And he says, well, okay, I'll take your money, and I'll give you your performance back. So that's really nice. A lot more control and a lot better ability to handle noisy virtual machines, to handle virtual machines with high I/O demands. So the final thing I'm going to demonstrate here is some of the enhancements that we've made to Replica. I think that's the final thing. I'm looking at my list and squinting. Yes. So Hyper-V Replica in Windows Server 2012 was easily one of our top features. People were really happy that they could now do disaster recovery without having to buy specialized hardware. That they could do disaster recovery, and have VM replication on standard hardware. But it was a V1 release. We tried to do a good job, but with a V1 release, obviously, everyone has new scenarios. And we spent a lot of time going out and talking to people and going like, okay, how can we make this better? What do we need to do here? And honestly, we got a list that's long enough to keep us busy for a decade. So we didn't do everything on that list, but we did choose 2 key areas where we said, okay, we're going to go out and we're going to address this in R2. So for the first one, I'm going to show it by just enabling replication on this virtual machine. And this is going to look very similar. If you've played with Hyper-V Replica, you know where this is going. So I'm going to go, over Kerberos. I don't want to send the page file. OK, here's the first change. In Windows Server 2012, Hyper-V Replica sent any changes every 5 minutes. If you're a disaster recovery nerd, now you will put on your spectacles and your pocket protector and say, that means an RTO of 10 minutes. But we sent them every 5 minutes. And it was really interesting. Every person we talked to wanted to be able to change this, but for different reasons. So the most common one, the 2 most common ones we heard. The first one is, we designed Hyper-V Replica for small and medium businesses to be able to replicate to a local service provider or to a second data center. And we had so many people come and say, well, that's great, but what I really want to do is I want to do a replica from one side of my data center to the other over gigabit. Heck, I actually do this in my house. I have 2 servers side by side, and I run replica between them. So for those people, we're providing the option to say every 30 seconds. So every 30 seconds. And what this means is we provide a guarantee that that secondary virtual machine will never be more than a minute behind the primary. Let me just highlight, if you want to get that sort of replication in hardware, you're going to be paying a lot of money. And this is now available and in the platform. On the flip side, the other one that we got was we got people who wanted it to be slower. And for that, we now have the option for 15 minutes. So why would you want it to be slower? Well, we talked to a lot of people who are like, well, you guys designed Replica to go over residential broadband and so on, but I'm trying to do it over a satellite link. Yeah. I met with the education department of Saudi Arabia. And they're like, we got this little school, and it's in the middle of a desert, and there's a satellite, and we went, fine. So what the 15-minute interval really gives you, one, we try and send data less often, but 2, it actually means that we have a much larger tolerance for connection downtime. With a 5-minute window, we will put a replication relationship into a failed state after an hour. With a 15-minute window, we will put it into a failed state after 3 hours. So I'm going to go with 30 seconds for this demo. And the rest of this is fairly standard. Nothing's changed here. So I'm going to go ahead and establish this replication relationship so I can show you the second change that we've made to Replica. So there we are. So now over here on Replica 1, if we refresh, I have my Replica virtual machine. And here we are, replication data, yada, yada, yada. So we had a really interesting moment when we got Replica out there. And personally, luckily, I'm one of these people who I enjoy being wrong. I don't think I would last long working at Microsoft if I didn't enjoy being wrong, because I get told I'm wrong a lot. So when we were designing Replica, we were like, yeah, we want to build this for small and medium business. And what we really want to do is we want to make it work for the guys who are so small that they don't have multiple sites. They just have a handful of servers in one location. It's like, well, how are we going to make that work? Well, we're going to need service providers to complete the picture here. And we did a lot of work in the first release of Replica to enable this. So we allow you to do Replica, across different domains, across different management spaces. We do Replica over HTTPS so that you can just do it secure over the internet. And we did a lot of work because we had this vision where we're like, we want local service providers to be able to go out to people and say, yeah, $10 a month, and I'll give you a recovery site for your virtual machine. We thought that would be great. So we built this all, and we went out to service providers, and honestly, half of them didn't go for that. And it was really it was one of those embarrassing moments and I had the same conversation over and over again, because what they said was, yeah, I get your idea. I like your idea. I like that. That'd be a good service for us to provide. But I'd rather use Replica myself. So it turns out that most service providers, when they looked at this, went, yeah, but I have multiple data centers, and I have an SLA with my customers, and Replica, I could use Replica internally to reach that SLA for less money for me. And for a lot of these guys, they were now having to do the trade-off of, do I offer this as a service to people, or do I use it myself? And a lot of them were saying, I'll use it myself. So what we've done is we've now added the ability that I can come to this replica machine, and I can say, and let's make another replication of it. Can I extend the replication? So here, I'm running on Hyper-V. I've replica to replica 1, and now I'm going to replica on to 2. And this wizard, actually mostly the same. A couple of things are missing, because we don't let you change the hard drives again and so on. Important thing, we do let you change the authentication method. So it's actually, for the scenario I was talking about, if you think that first replication hop, it's going to be HTTPS, but once you're inside the service provider environment, they can use Kerberos. It's their environment. So we do support mixing that. I can change the frequency. Go ahead, set this up. So I always get a question about this, so I'm going to answer it ahead of time. I'm a big fan of answering questions ahead of time. The only supported scenario that we have for extended replication is A to B, B to C. We do not support A to B, B to C, C to D, D to E. We do not support A to B, A to C, A to D. We do not support A to B to C to D to A. That would be bad. The only thing we support is A to B to C, because this was the big scenario that we got asked for. So with that in mind, let's switch back. So a summary that I'd like to give. The first one is Hyper-V for private cloud is just getting better. If you're having fun and enjoying Hyper-V 2012 for private cloud, 2012 R2 is just going to be better. Next one, increasing virtual machine uptime is always a priority. You'll notice that a lot of the new features we did, the zero downtime upgrade, the live resize of VHDX, the live export, it's actually all about keeping your virtual machines running. I like to say that when it comes to server administrators and uptime, they're like kids in candy. You can't give them enough. But it's always a priority for us. We're always listening, and that's, big ask to you. I come and I do these presentations, but for me, the real value of these shows is hearing from you. So please, track me down, ask me questions afterwards. Like, if you can't find me, you can go to the server section of the floor and start asking for me. They're going to send you there are a couple of people who are running my calendar this week. I do not have control of my own calendar. But they will find me, and I'd love to chat about what you're doing and about problems you have, questions you have, so on. The final point is, we're going to continue innovating in virtualization. I've had a handful of people come to me after the 2012 release and say, so you guys are done now, right? Right? No. We're not done. Trust me, I've got a list that could keep my team busy for a decade, even if I don't listen to you guys. No, we are going to continue innovating in virtualization, and we just want to make this bigger and better moving forward. So with that in mind, we've got a couple of minutes. I'd like to open for questions. Got one there?
Yeah, look, I was just wondering, in 2012 R2, is there any increase in performance difference from core to GUI?
So the question is, in 2012 R2, is there any performance difference between a core installation or an installation with the GUI? Yes, but not really. So the biggest, actually, let me be really clear on this. The biggest difference here is going to be your memory utilization and your memory footprint. So there's actually, and this is, I make people angry when I do this. Let me talk about some feature work that we did that I just didn't mention in the slide. We did a lot of work in R2, and I'm close to running out of time. So we've actually, one of the problems that we've historically had has been if you're using a system that's heavily utilizing memory and you have dynamic memory, you can actually start to run into contention for the memory usage in the host. So we tell people don't run applications in the host. People do. But even if you're not running applications, we've seen situations where like people just had a dozen guys using remote desktop to connect to the host. It starts using memory, and you start getting memory contention. So in 2012 R2, we are actively monitoring the memory utilization of the parent, and we pulled that out of dynamic memory. So for the question about GUI versus core, the biggest thing you're going to notice is if you're running GUI and you have people who aren't following our best practices and they are running stuff in the parent partition, then you're going to get less and less virtual machines running just because we're pulling away the memory for that. So memory's the biggest impact. Storage, nah, zero. It's exactly the same. CPU, honestly, is negligible. Most if you're running full, you've got a bunch of services, a bunch more services, and so on. But most of the time, that code's not doing anything. So memory is the biggest impact. Any other questions?
Any extra remote FX?
Sorry, I didn't hear that.
Remote FX, is it enhanced or is it changed?
So the question was, any enhancements around remote FX? Not the sort of enhancements that I'd talk about on stage. Honestly, there has been a lot of work on remote FX, but it's really been more focused on just like buttoning down seams and making the end-to-end scenarios work better. So nothing big on stage.
When the Hyper-V installs, it removes a certain number of processes from your total available pool. Is there any way of controlling that or seeing how those removed processes are performing?
So the question is, and this is something that we introduced in Windows Server 2012. In Windows Server 2012, if you have more than 64 logical processors on a physical system, and you enable Hyper-V, we actually hide the any more than the 64 processors from the host operating system. And we did that for a couple of reasons. The first and foremost is, frankly, the host operating system doesn't need all of those processors if you're following our best guidance, and I know that you're not because I've talked to you before. Naughty person. I made that connection as I was saying that. I was like, I know, I talked to him last night, and he's running stuff in the parent partition. So the question is, do we provide a way to control that? And the answer is, for the room, yes. For you, no. And I do actually mean that genuinely, because we do provide a way to control it, but we only allow you to reduce, and you want to increase. So sorry. The maximum that we support for the parent partition is 64 virtual processors. If you go digging through the BCD edit documentation, we do allow you to go in and bump that down. We don't like to talk about it because honestly, folks, don't do that on a production system. Our nightmare scenario that we know is going to happen one day is we know that someone's going to take a 64 VP box and configure it so that the host only gets 2. and then they're going to complain to us about performance, and it's going to take us a day and a half to figure out that they've been morons. Don't play with that, please. You can have a look at it in a dev test environment, but not in production. But yeah, unfortunately, no, you can't get more than 64 VPs in the host operating system. Any other questions?
Is there a quick way to determine which VM is causing the high I/O?
So actually, that's a fantastic one. Is there a quick way to determine which VM is causing the high I/O? Let me trip over that. Yes. Yes, I do. I'm just to give some context, I've got like 4 minutes left on the timer, so I didn't have time to demonstrate all of this. I demonstrated the IOPS control. While we were doing that, we've put in full performance counter support so that you can monitor IOs on a per VHD basis, on a per VM basis. We've also integrated IOPS monitoring into our metrics platform. This is really nice. You can go in on a virtual machine and you can say, hey, Hyper-V, track IOPS on this virtual machine. And you can come back a week later and say, okay, what's been the average IOPS? What's been the maximum IOPS? That is all fully plumbed throughout the system. So that's actually really fun to play with. So the question is that new in R2? So what's new in R2 is specifically the storage I/O aspect of that. Windows Server 2012, we implemented a full metrics platform. It's only exposed through PowerShell, but you can go in and in PowerShell you can say, hey, monitor CPU, memory, network, and in 2012 we allowed you to monitor disk utilization as in space. In 2012 R2, we've added the ability to track the IOPS utilization as well. But it's a great tool because it's very lightweight. You go in there and say, yeah, and you come back at arbitrary period of time, and you can see all the utilization data about the virtual machine. So the question is that rolled up into SCOM or VMM? Not yet. They're working on it. This is, what? I don't talk about the future. Apart from, we're going to continue working on private cloud. You can quote me on that. I'll be OK with that. So any questions up the back? I haven't seen any hands up there.
Are there any roles you don't recommend using Hyper-V replicas with?
So the question is, are there any roles that you don't recommend using Hyper-V replica with? So it's actually kind of a tricky one to answer. If you've been around Microsoft for long enough, you'll know that a lot of the application-specific guidance comes from the application teams. So for Windows Server roles, no, they all work. The only role that we had some concerns around was Active Directory, and we did a lot of work in 2012 with the Active Directory team to make sure that that all works fine with Replica. We've also been working with the SQL and Exchange teams to get their guidance out about Replica. I know the SQL team has signed off and said like, yeah, that's fine. They, of course, do have their caveat in there where they would prefer that you're using the built-in SQL replication. Honestly, I can't remember what the Exchange team have said. I've been lucky enough to not be involved in that document. So I don't remember off the top of my head.
Is there any changes to the software-defined networking in R2?
So the question is, are there any changes to the software-defined networking in R2? There absolutely are. I believe we have a separate session for that. I don't have that off the top of my head. But there absolutely are. There's a number of performance improvements, a number of stability improvements. The biggest one, of course, is we're introducing the multi-tenant gateway in box as a scalable application. The biggest complaint we got about network virtualization was that we relied on third parties for that gateway. So I do not know the session off the top of my head, but I know there is a network virtualization session. I would just check through for that. Okay, I'm going to take this. This is going to be the last question because I am now 48 seconds. I have to answer this question in 48 seconds.
Can you live resize a fixed VHD?
So the question is, can you live resize a fixed VHD? Yes. And I've got 36 seconds. We can. First, actually, let me be clear. It is VHDX only. But fixed dynamic differencing, that all works. Any VHDX that you want, you can increase, you can reduce, you can do it all live. So I'm going to wrap up now. Thank you all, and I hope you have a great show.